Okie dokie. Here we go. 6-1. We're going to be looking at circles. Instead of having handouts, what we're going to do is pages 229 to 232. Actually, I think it's 232 is the end of some practice problems. But these are going to be your pages that you're going to fill in instead of doing the worksheet. Okay? So get your books. You might want to pause it. Go ahead and grab them. Be ready to go. Okay, so here is our happy circle. You can see our circle is happy because we have this nice circle here, and in the middle with the nose, that is our center, which I did not label. So that's our center. And we have from the center to the edge of the circle is a radius. And notice that the radius on one side is the same as the radius on the other. And that 2 radii going across is the same as a diameter. The circumference of the circle, the C, is the distance all the way around the circle. So I just wrote those down over here. Diameter is equal to 2 times the radius. That's what we see here with our happy circle. Now the ratio of the radius over the circumference is pi, is what we call this. And the number that we will use is an approximation, and that is 3.14. Now, in your book, the first exploration they have you do is they want you to take a paper circle and they want you to fold it and cut it in half and cut up the pieces and lay them down together. So I encourage you to do that. But what I've done here is I've just taken and I've drawn basically what you should see. If you follow their directions, you're going to have 4 wedges without shading and 4 wedges with shading. And when you stick them together, they're going to look pretty much like a parallelogram. All right, now what's going to be this relationship of the area of the circle when we cut it up and put it together like this, or when we start with it in a circle? Well, hopefully you see they're going to be the same because all you did was cut them up and rearrange them. You didn't change the area. Now the base of this, meaning this distance here, the base of this is going to be about half of the circumference. Now hopefully you can see that because half of the circumference is on the bottom. 1, 2, 3, 4 parts of the circumference go along the bottom, and 1, 2, 3, 4 parts of the circumference go along the top. So if there's 8 parts and only 4 on the bottom, that's half of the circumference. Now I do have over here, remember, to help us remember that the circumference, the formula for circumference is going to be pi times the diameter. So 1/2 of the circumference is 1/2 pi times the diameter, which is equal to 1/2 pi times 2 times r, because remember diameter is 2r. So 1/2 the circumference is going to be pi r. Okay. Now the height of this guy is going to be, if we take from the tip down, well, that's going to be a radius. It's going to be equal to 1 radius for how tall this guy is. All right, so now if we take an area, and how do we do an area of a parallelogram? Well, it's the base times the height. So we take the area for the parallelogram, and we have base times height. The base, we just figured out that 1/2 the circumference is equal to pi times r, and the height of this is equal to r. So pi times r, well, that's going to be our famous area of a circle equals pi r squared. Okay, so to summarize, the circumference of a circle is equal to pi times diameter. The diameter of a circle is equal to 2 times the radius of the circle. Pi is the ratio of radius to the circumference, which is going to be approximate 3.14. And the formula for area for a circle is area equals pi r squared. Now in example 2, they give you some information, and what you need to remember is that the diameter of a circle is 2 times pi. 2 times r. So in this problem, they give you a diameter of 50. So if 50 is equal to 2 times r, well then the radius is going to be 25. So to find the circle, the area of this circle, we now need to use area equals 2 pi r squared. So we put in 2, and then we put 3.14 for pi, 25 for r, square that, and we come up with an area of 3,925 feet squared. Now, For 2A, you do need to read the question and double check. Does this make sense? So, and then 2B, they give you another problem, and there's basically they give you that radius is equal to 52 feet, and they want you to find A. So go ahead, pause the video, and take care of that. Now, for example 3, they're doing something a little different. They're giving you the area, which is 50.24 inches squared. Now we have to remember that the area is equal to pi r squared. So when I start to replace these numbers in, the area I'm going to replace with 50.24 inches squared. Now, it's kind of squished, but I've put my units here. That's really important, especially next year when you have to deal with chemistry. Okay, so we have our 50.24 inches squared, and we're going to approximate pi with 3.14, so we have this is equal to 3.14 times r squared. Now when we divide both sides by 3.14, remember that's how we get r squared by itself. Okay, if we divide both sides by 3.14, then we end up with r squared is equal to 16 inches squared. Notice I brought my units down with it. So to find out what r is, I need to take the square root of both sides. So the square root of 16 inches squared is equal to the square root of r squared. Now remember, the square root of a square is just that value. So the square root of r squared is r. The square root of 16 is 4. And the square root of inches squared, just like we did here for r squared, square root of inches squared is going to be inches. So r is equal to 4 inches. Now this isn't on your paper, but make a note on the side. Why did we not use the negative value? Hopefully that's really obvious to you. If not, check with somebody, check with me. All right? Now, your diameter is going to be 2 times your radius. So 2 times the 4 inches, well, that's going to be 8 inches. So then the question, will this 7-inch fork fit on the plate? All right? So you need to answer that. 3A, they want you to explain how to find r given A. Well, guess what? You just did that. Example 3 is finding r here, given A. So you've got A. So basically explain what we did here for 3A. Now 3B, they want you to find R and they want you to find D. And they've given you an area of 78.5 meters squared. Now in class we will be working on page 233, 234 for the homework problems. If this all seems to make sense to you, please feel free to work ahead.